So we're going to review our sine and cosine graphs from last time. We'll do the quiz on them next time. So does anyone remember what shape these graphs were, like what they looked like? Remember this? Okay, so a wave. I know you're not on the Chromebook. Go ahead and close it for me. So they're going to wave both directions forever. So your domain is automatically all reals. Like that is the answer. On your quiz, that's the answer. So you're going to at least get that one, right? Yay. I would wait on the range until you get the picture. Amplitude. Do you remember which part of the equation gives you that? The number up front, it's the vertical stretch or shrink. It can't be negative, so just make sure you absolute value it. Now, this one doesn't have anything written out front, so what is really like in front of that cosine? A 1. And it means when you do your wave, it's going to wave 1 unit above and below that center line. All right, the period is typically 2 pi, which should make sense. That's once around the circle. You put 2 pi over whatever's in front of the x. Now, I took it easy on you this one as well, because what's in front of the x there? 1. So 2 pi over 1 is just 2 pi. In other words, it did not stretch or shrink. It stayed the same, which is good. Phase shift. What part of this is the phase shift? Inside, it's the left or right. So did this one move left or right? Went right, pi over 2. Remember, that one's kind of backwards. So you can either just write positive pi over 2. You can put a plus sign in front of that if you want. You can write right, R-I-G-H-T, pi over 2. Those are all correct. And that is where you're going to start your table. You start wherever you've shifted to. Do you remember this? I know like a weekend happened, but is this ringing any bells? I woke you up, so you're not allowed to sit there and act tired, right? And then what's your vertical translation? 3. Or you can write up 3, because it moved up 3. All right, so you start with wherever you shifted to, and then you add the period, because you want to do one cycle of the function. So if we start at pi over 2, and we add 2 pi, what do you get? It's 2.5 pi, but we would write it as 5 pi over 2. So what's halfway in between these? Yeah, 3 pi over 2. 1, 3, 5. Do you remember me drawing a number line and saying you could just leapfrog your way to the middle? You can always do that too if you don't like fractions. And then what's halfway in between 1/2 and 1.5? Yeah, that's going to be 1 whole pi. I do get some people that like writing 2 halves because they want to stick with the halves. It's like 1/2, 2 halves, 3 halves, and then they would put 4 halves here. That's fine too. But what would go in this one if we like reduce it? 2 pi. Good. Now, it really doesn't matter what that says though, because no matter what, you're just going to go around your unit circle. I've got my sticky note here and I've got it on the board behind me so you can see it. Now, when you go around here, we're doing cosine, and I like to box that in. Is cosine your x values or your y values? Cosine is x. And then whatever numbers you get, you're going to multiply them by 1 out front, which isn't going to change them, and then add 3. Okay, so starting at the beginning of your unit circle, we're just going to start right here. What's your first x number? 1 plus 3 is 4. We're going to journey around the circle. So now we're going to go up here. What's your x value? 0 plus 3 is 3. All right, then we're going to come over here. Your x value is -1 plus 3, 2. Now we're down here. What's your x number? 0 plus 3 is 3. And then what's the last one? Always. Same as the first one. Wherever you started is where you're going to end up. These are cyclic. They follow a cycle. So it's going to end up where it started. Then you have to label your tick marks. Do you see how these count by halves? Okay. Do you remember me telling you, you don't have to label every single one? In fact, I don't want you to do that because they're going to be itsy bitsy and impossible to see. Skip the first one and just call the second one pi. Then you know that the first one is 1/2 a pi. You don't have to label every single one. So skip another one and then call the next one 2 pi. Skip another one and call the next one 3 pi. And let's just label at least 3. I think that's a good number. Let's just label at least 3 of them. And then you basically just plot the points. Pi over 2, 4, be right there. And then pi 3, be right there. 3 pi over 2 gives you 2, and then it's gonna go back up. Now, I'm not here to grade your art skills, but remember me saying it can't look like a jack-o'-lantern mouse, like it can't be all jagged. Make an attempt to make it a nice smooth curve. And then also you have to do at least one more cycle. I need for you to show me that you can continue the pattern. You can go to the left or the right. Usually if there's space, I'll go to the right. But I need you to just keep that going for one more cycle. And if you make a mistake, you're pretty much going to know because your graph is going to be super wonky. Do you know what I mean? Like it won't look symmetric. If you have a point that's off, you're going to be able to look at it and go, oh, that isn't right. And then don't forget to go back and do the range. What 2 numbers, and you want to do the smaller one first, what 2 numbers are you caught in between here? 2 to 4 and parentheses or brackets. Because there's actually points there. So from 2 to 4 is your range. Do we put arrows on the ends of these? Why not? Yeah, it's not gonna like, this isn't gonna just go down forever and ever and ever. It's gonna keep waving. So just don't put an arrow. So what I'm gonna do is pause the recording. I want you guys to try this one. The only difference in the process is because it says sign. When you go to pull your values from the unit circle, what are you gonna use? Use your Y values for sign. But I want you to just give it a try, and then of course I'll go over it. All right, domain is gonna be everything. What did you put for amplitude? 3. It is the absolute value of -3, which is 3. You don't have to write that if you don't want to. If you just put 3, that's fine. But if you put -3, then I have to take off. So just be careful. It's a distance, so it can't be negative. All right, the period. You put 2 pi over whatever's in front of the x, which in this case is 4. So 2/4 reduces to a half, so that's pi over 2. So look, here's what happened. We took the graph and we squished it this way. Do you get what I'm saying? Horizontal shrink. It's going to be scrunched together. Phase shift, what'd you put for that? That's the left or right. 0. There isn't one. Or you could write none or NA is fine. But do you see how there's nothing added or subtracted in there? And so let me 0. And then how about vertical translation? Also 0. There's nothing added or subtracted out here. All right, what goes first in your table? Yeah, 0. It's where you started. I'm going to put 0 pi because I like to put pi with that. If you don't want to, that's fine. Personal preference. Then you add the period, which is pi over 2. So 0 plus pi over 2 gives you pi over 2. All right, now it's fun with fractions. Hey, guys, what's halfway in between 0 and a half? Yeah, 1/4. Good. Halfway in between 0 and a 1/4 be an 1/8. Half of a 1/4 is an 1/8. You get we're breaking it down by halves. Let's try again. If you break down halves, they break down into what? 4ths. And 4ths break down into, in theory, 1/8 would break down into, good. Now let's try it with a different number. What would 1/3s break down into? 6. 6 would break down into 12ths. In theory, I wouldn't do this to you, but 12ths would break down into 24. Okay, good. We got that. Making sure. Now, what goes in this one? I know it's like, hey, what goes there? Let's count. This is no 8ths. I heard someone say it, one of you that guessed got it right. This is 1/8, this is 2/8, so this would be 3/8, and then a half is 4/8. Told you it'd be fun with fractions. And here's my pep talk. I'm gonna say it on the recording this time. Let's say you couldn't get that. It's difficult. Fractions are hard. Make something up because you can get the other half of the table without it. You don't need it to get the other half of the table. You're going to go around the circle and take the y values and then do what with them? Multiplying by -3 and then add nothing. There's not another number out there. All right, what's your first y value starting at the beginning here? 0 times -3, 0. Look, so you don't need the other part of the chart. Going around the circle, what's your next y value? +1 times -3. Good. And then the next one is 0. And then when you're down here, your y value is -1 times -3, +3. And then what's the last one? You're back where you started. So you can get that without even getting, like, you can make something up for this if you get stuck. I'm not saying just make something up. I want you to try, but if you get stuck, you know, fine. Now you want to count by 8s. What's the easiest way to make sure that all of these are 8s? Oh, that's a good idea. I was going to say go to the 8th one. 4, 5, 6, 7, 8. And what would I call the 8th one? I could call that 8th one pi. Halfway in between would be pi/2. And if you did halfway in between that, you'd have pi/4. That's enough, as long as you label at least 3. And I don't care which 3 you label, but it has to, you know, be structured. But then you can just go ahead and plot these. We're going to start at 0, 0. And then an 8th, you get -3. Back up to 0, +3, back down to 0. It's harder when it's real stretched out, but again, try to make it a nice smooth curve. And then I just want you to continue that one more time, like do that again. So down here, -3, back up to 0. And again, if you make a mistake, it's gonna look wrong. Like, it'll be off. Like your graph will look wonky if you get a point in the wrong spot. And then what is the range? Don't forget to go back and answer that. Yep, -3 to 3. Again, I like to leaf through the test and try and catch that if anyone leaves something blank and give it back to you, but I can't catch everything, so you gotta be careful.